So now we're going to talk about inheritances. Excuse me. Now we're going to talk about interfaces. Interfaces are a form of superclass that consists only of abstract methods. So rather than continue with our student and employees, we're going to make it brand new. So make a brand new project. And again, I'm going to be a terrible programmer and put all of these in the same file when I should not. Each class should always go in its own one. It just makes it easier to project on the screen. Okay, so you can't put more than one public class inside of a Java file, so the rest of them are not going to be public. We're going to use the word interface to define this one, though. Interface. And we're going to call this one, I don't know, a GeoShape, geometrical shape. And we're going to decide, what do we care about GeoShapes? Every object that inherits from GeoShape, although from now on I'm going to say implements, every object that implements the GeoShape interface has to do two things. It has to return the area, and it has to return the perimeter. So let's make these get area, ought to be public, public double get area. It's an abstract method, so it doesn't have any body. As a matter of fact, if you try to add a body to it, we'll get an error. So I'm calling get area and get perimeter. Let's try adding a body. Let's just make it return 0 and see, yep, I was correct. It says abstract methods cannot have body. So we just need to rip that body out. There we go. And again, it looks like C++ prototypes. Now we're going to create a class called Circle and a class called Square. Each one of them implements this interface, meaning that each one of them has to have a get area and a get perimeter. So class Square, what is his data? Well, his data is the length of a side. We're going to note that he implements GeoShape. It's giving us an error because we have not implemented these abstract methods. We need to implement both of these abstract methods before our error goes away. So I'm just going to copy those and paste them underneath there. And what is area of a square? It's just side times side. Return this dot side times this dot side, or however you like to word it. And what's the perimeter of a square? It's 4 times the length of the side. Return 4 times the length of the side. I think I'll squish the methods as I have been doing, if I can get them to look pretty. Don't know if I can. Yeah, there we go. Okay, we implemented the abstract methods that are required in order for Square to successfully implement the GeoShape interface. So that means that every square and everything else that implements the GeoShape interface is guaranteed to have an implementation for get area and get perimeter. So down here, when we add a print method to our main method, we can rely on that stuff. Down here in main, I can do this. Square s is equal to new square s dot side is equal to 10, and I can print out his area and his perimeter. System.out.println square plus the square's area plus a space plus the square's perimeter. Really, it ought to be a little more informative, like say A is equal to, so that we know that that's the area, and P is equal to, so that we know that that's the perimeter. That's a little bit long to fit on one line, so I'm going to break it up into 2 lines. So when we run them, we did successfully create a square. It has an area of 100 and a perimeter of 40. And then we think, well, that's so cool, I want other objects. I want to implement a circle. So we have one object that implements GeoShape, but we could make another one. We can make a circle. There's something I'd like to do first, though. Instead of printing this out here, I'd like to move this up into its own print function, kind of like we did. So I cut that print statement, and I'm going to make a public static void print, and it's going to accept a GeoShape as its argument. And then when I'm ready, I'm just going to print my square. Whoops. There we go. And it's going to behave the exact same way as it did before, because all I did is move that up into its own method. So here we go. We have a square. Let's add a circle class. A circle will also implement the GeoShape. Let's remind ourselves, in order to successfully be a GeoShape or to implement the GeoShape interface, we need those 2 methods. So, class circle implements GeoShape. Now for a circle, we don't care about the side. Instead, we care about the radius. So public double radius. Why am I getting an error? Because I have not implemented the required methods. They are defined as abstract. Every method in an interface is abstract. So let's go ahead and copy these guys again. Where should I copy them from? I'll just grab them from here. Paste them. Take those semicolons off. What is the area of a circle? It is pi r squared. So return math.pi times radius. And I should have made it this dot radius times this dot radius to be consistent. And the perimeter of a square is really more accurately known as a circumference. But I'm not going to change its name because then it would no longer match this. And the perimeter of a circle, the circumference of a circle is 2 pi r. Return 2 times math.pi times radius. And again, if I was consistent, I would make it this dot radius and this dot radius, or I would make it math dot, yeah, I can't handle this. I got to make it look better. Math.pi times math.pow, this dot radius to the power of 2. I think that's not going to be any shorter than what I was trying to avoid. So I think I've goofed. Yeah, drats. There, barely. Make this one this dot radius as well. This keyword is usually not necessary, but I strongly encourage people to go ahead and adopt it. Alright, I just noticed something, that when I run my code here and it prints out what it is. It prints out that it's a square, which is great, but I also want to be able to print out circles. So I don't like having that hard-coded there. I think the fix that I'm going to do is to go back up to my interface and add one more abstract method called getName. It's a string rather than a double. That means I have to add that function, that method, to each class that implements that interface. So down here in circle, getName is going to return the word circle. That's his name. And square is going to do the same thing. Public string getName return square. That way each object can announce its own identity for better printing. And again, I'm getting all these little warnings here. It's wanting me to add the override annotation, but since it's not necessary, it makes the code harder to read. I'm going to leave that off. Alright, let's see here. I have getName at the bottom of circle and I have it up at the top of square. I don't like that. I want them all to be in the same order. So I'm going to cut that and paste it. That doesn't really matter. Notice these gray circles periodically. If I hover my cursor over it, it says has implementations. That means that something implements the GeoShape class. Sure enough, we see that it's implemented here and here. But say they were in another file, which they should be, since every class and every interface should have its own file. I can click on that and it would take me to one of the implementations or the other implementation. So getName, I could click on the gray circle and it would offer every object that implements the getName method. So that's kind of cool. Alright, we're back at print. This is getting a little bit messy. I'm going to change it to a printf. So I'm just commenting that out for now. I'm system.out.printf. Let's print out his name, %s, his area, %.2f, since he's a floating point, and his perimeter, %.2f. Then we need to fill in those placeholders with the appropriate data. Really want my comma here. Put that on the next line. s.getName is the first item. s.getArea is the second item. And s.getPerimeter is the third one. Okay, now I feel safe in getting rid of that. Make sure I haven't broken it. I'm going to run it. It says name, square, area 100, perimeter 40. And I didn't put a /n at the end. I will go and do that. Maybe I'll add a tab between each thing. Now to be a little bit better spaced out. The name is a square, the area is 100, and the perimeter is 40. Sounds right for a square with a side length of 10. 10 squared is 100, 4 times 10 is 40. We don't have a circle yet, but we're going to create a circle. So we have a square object, but a little while earlier we implemented a circle as well. Let's go make a circle. We'll come down here. Circle C is equal to new circle. And the circle doesn't have a side, but he has a radius. He has a radius of 10 too. Now let's print out the circle. Now this print statement is working, Because both a square and a circle implement the GeoShape interface. So both of them can be accepted as a parameter to fill in, as an argument to fill in that parameter. But the behavior is going to be very different. When we call getName, if it's a square, it's going to go to the square's getName and print square. But if we pass it a circle, it's going to go to the circle's class and call getName, which is going to print circle. So there we go. We ran it, we called print, and it printed out a square with an area of 140, and here we did a radius of 10, which is considerably larger, really. It's got an area of 314 and a perimeter of 62, circumference, really. So now we are touching upon the idea of polymorphism. Polymorphism is when you have objects that behave differently based on the interfaces that they implement. Let's go look at the definition for polymorphism up here. Oh, okay, I guess that's in chapter 14. So polymorphism is when you have different objects that respond differently to the same method call. And we have that going on. If we come back and look at our code, if we call getName, if it's a square, it calls that one. If it's a circle, it calls that one. So we're using the same method name, but it's behaving very differently. These objects are behaving very differently even though they are using the same method calls. If you call getArea, then the formula for a circle's area is completely different than the formula for a square's area. Yet it knows. This one function call is treating the object one way or a different way based on what type of object it is. Last change we're going to make is create an array list of these geometric shapes. I'm going to have to add an import for it. So GeoList, and everything in the list is going to be a GeoShape. Can I type? I'm just going to call the list shapes is equal to new array list. I get an error about the import. I'm going to add the import. Let's add the square to it. Shapes dot add the square. Shapes dot add a circle. Let's create another circle and add that one as well. Circle dot, or circle C2 is equal, I'll just reuse the same reference. No, I won't. Circle C2 is equal to new circle. C2's radius is just 1. We're going to add C2 to the shapes. I want to comment out these print calls because instead I'm going to write a for loop that will print the array list. Come down here. We have added 3 shapes to our array list. For every GeoShape, I'm going to call it G, in the shapes list, print that shape. So I run it. We have 3 shapes in our shape list. First thing is a square. And it called all the methods from the square class. Even though they have same names, they perform very different functions. Then we added a circle. And then we added one more circle. So the same statement here, this print statement, is engaging in very different behaviors based on the identity of the object, the type of the object. And that's polymorphism. Polymorphism is when different types of objects respond differently to the same method call. So the last thing I will mention is that usually it's a good idea to add a toString method to all your classes, and we haven't done that. The other thing that's really good is to make your data private and your methods public. In order to get that to happen, I would have to add getters and setters for the radius. And there's a quick and easy way to do that. I could highlight that variable radius and go refactor, encapsulate fields, and add a getter and a setter for it. And miraculously, that even fixes it down here so that when we make a circle, we call set radius. And I should do the same thing for side. So I'm going to highlight side under square and do refactor, encapsulate fields, and do that. And if I was going to continue being a good programmer, I would create these, I would move all of these over into their own files. The interface ought to be in a file called geoshape.java. The circle ought to be in a file called circle.java, and the square ought to be in a file called square.java. Now when you let it add your getters and your setters, your accessors and the mutators, it puts all sorts of, Java comments on it, which I usually go and clean up. So I'm doing a little bit of cleanup so that I can just have a final shot of each one of these classes. We didn't make any changes to the GeoShape class. But for circle, we did make a change. We added getters and setters for our now private variable. So this is the final version of the circle class. Almost meets my criteria for a good class. I think it ought to have a toString as well. Then the square class. Let's clean up the stuff that got added, make it look like this. And that's the square class. Then we have a print method that uses printf to call those 3 methods. That's where our magic occurs. That's where the polymorphism is engaged. And here is our main method. I'm going to remove these print statements to shrink it down a little. I'm going to move this circle creation up here above the array list creation so that we just have 3 add statements in a row. And there we go. That is our main method. We create a square, we create a circle, we create another circle, we create an array list, we add our 3 shapes, and then we use a for list to print all those objects. And the printing manifests the polymorphism by engaging in the specific methods inside the specific objects in order to handle data of that particular type, either the squares or the circles. Well, I hope this has been educational, and if you have any questions, please contact me.